Hello, class. This is an overview of Bowerman's Chapter 7. We're turning the corner now as the lecture had gotten into. And instead of just looking at the population of the data, that we have some, let's say we build 10,000 cars, and we're looking at the mileage on those cars, and we have all 10,000 points. Now we're looking at the case where we're building so many cars, it's too expensive to look at them coming off the line, and we're going to have to pull some samples out of there, and we're going to have to take a look at that data and start wondering whether the larger population is represented by the estimates that we're making by these samplings. So there's some degradations that go on because we're not looking at the entire population. Before we get started, the shortcut here that hopefully you keep situational awareness as we're going through here is there's three sections in chapter 7 that we're doing, 1, 2, and 3. Okay, as simple as that. Okay, so part 1 of the chapter is going to talk about sampling at all. Okay, and there's a few things that we want to know about that. Keep that in mind. That it's a total random sample, meaning that all members of the population are available for us to pick in the proportion or ratio that they appear in that population. Okay, there's no dependence. There's no. It's as if, as I used in the classroom here, if you go into Starbucks and you get a fresh cup of coffee, you're still at the counter, you take your first sip after you pay for it. Well, that's a pretty mixed solution or whatever suspension of coffee that you have there. And the temperature that you take when you sip it is pretty much consistent through the entire coffee because of the way it spins in the coffee when they pour it in and whatnot. Now, if there's a pool in your backyard, built-in pool, let's say, half of it's in the sun, half of it's in the shade, and nobody's been there all day, and you get home from work and you jump in the shady corner that might be very shallow, might even have an effect on it. It's going to be cold because the water hasn't been circulating. Let's say your filter wasn't running. No, there was no circulation of the water there, and so it depends when and where you pick your samples from that pool of the temperature. If you jump in the sunny side of it, if any of you swim, when you swim in a pool, that you go through these warm and cold sections so it all gets mixed together. Okay, so we're talking about random samples here. We went from random variables to random samples. Okay, there's a few different ways things can be sampled. Basically, we stick to the scientific here. We're just doing entry level. This is exhaustive scientific testing. There's what did we run into a couple other things like expert. Sometimes when someone's been around the data and there's no reason to believe that the system has changed at all, that an expert can make uh, some conclusions about the data. And there was also one in here that we even called convenient. Okay, so if you're doing, let's say you hire some interns from Mount St. Mary's College and you send them over to the mall to take written, built clipboard style surveys, and if you get a bunch of timid interns, they're not going to go up to type 1 personality people entering the door. They're going to be selective. They're going to end up picking very demure, quiet people that are more like them, that cause no confrontation. And so you're going to get a very biased set. Okay, so that's a huge word in sampling, and any of the statistics we're doing is bias, right? So we're trying to avoid a bias where if you want to know, I don't know, somebody, some sort of survey that you're doing over there in the mall, and as I said, if you're not deciding to pick every nth or random person that comes through there, if you don't have some randomized approach to this, you're going to get a biased result because whoever your interns pick are going to be probably matched up to their own personality. So they'll pick all the quiet people, they'll pick all the forward people. Either way, you're going to get that. So that's what we really need to know about sampling. Okay, the random sampling as a topic in itself, that pretty much covers everything we really need to know. The book goes over a few ways of generating random numbers. You can do that in Excel. I've showed you how to do that. If you ever need to do this, you need to read the part of the chapter that talks about create a big table of these random numbers. And so the numbers they go from are between 0 and 1, 2, 3, 4, 5 places. Okay, so they show a table there, and they discuss how to use a randomized table like this when you might have, the example they give is 1 down to 15. There's 15 companies here, and you want to pick a random group of, I think they asked for 5. How do you pick random group out of this group of 15 by using a table like this? And so that covers actually 7.1. That's the first part here. Okay. Now when we get to 7.1, rather 7.2, and we get to 7.3, the only part of the rest of this video I want to talk about, very short here, is we have to remember what chapters, I believe it was 5 and 6 were about, and that's the difference between 7.2 and 7.3. 7.2 has to do with continuous variables, okay? And so if we're looking at the mileage coming off of these cars coming off a line, and we're sampling, and the average is around 31. We know the population is going to be something around 31, okay? That's the discussion that we get into in 7.2, okay? So if we know the true population is something around 31, the types of readings that we're going to get, if you look at it, they quantize them, okay? So in other words, how many digits did you go out to, right? So when we read, we only go out to the precision that's useful for the problem. And so, I mean, when they put these things through the test, you might get a car that has a 30 point, let's say, 1, 2, 3, 4, 5. That might be the mileage. You might go out to 5 decimal places, but usually this is a coarser measurement, so you don't need all these numbers. And so what you would probably do is just read to the 10th, okay? 30.1, 2, or 3, or 4, 5 miles per gallon, okay? In a continuous sense. Okay, so we're talking about something where it has a range, and it might range, if we draw this and it was normally distributed, and here's our average is 31, a real far outlier down here below -3 sigma, might be, I don't know, like how close to 31 do you think they hit? I mean, that's all I'm asking myself is, if you got a lemon and it was down at 24 miles per gallon, that's probably well outside -3 standard deviations down here, and so what was that? The separation here is 7, so it'd be kind of crazy if you got one that was running at 38. That'd be entirely ridiculous that instead of a lemon, you got a wonderful rainbow unicorn car that just way outperformed what they're calling as the average. But the possibility is that you are going to get one that's a little bit above, or you're going to get one that's a little bit below. That's the way it works out. Okay. So that's 7.2. How do we take a look at continuous data like that? Now, here's the big shift. Okay, up till now we've looked at the base data. Okay, so all the way up till now we've looked at a whole set. This is the population. Goes all the way out to plus infinity down to minus infinity. Okay, you need to make the shift. You have to understand what we're doing. We're using the tools of normal distribution in a funny way here. Okay, when you get into this, what you're going to be looking at is what we call a sample has n readings or observations. Okay, just as a short note here, it can either be observations or experiments, especially if you're thinking about something like medications, experiments. Okay, and there, what you do, you use a control. We talked about this in the lecture. You have a control methodology where you offer placebos. Okay, all right. So that's the difference between experiment and observation. Observation, you're just going out and you're trying to track the path of some undetected planet at this point. You can only read it. There's not much you can do to influence that, right? Whereas in medication, you're actually trying to cause a change or not, and that's under controlled double-blind studies here, where you have control of placebos or the actual medication. Okay, that's just a fine point of keep that in mind. We're trying to do the topology of sampling. So now we're getting into the important stuff. We'd never end the course before here because now we're getting into the things that you use to apply more frequently to what you see at work. Okay, so the sample, we have these observations. What we're saying is every hour we may sample 10 cars over the period of an hour. Okay, randomly sample every hour at some rate of every every 6 minutes. That would be we pull a car off. Okay, now you would probably be a little bit more careful in reality because the fact that you set up a systematic interval here of 6 minutes, you might mask a problem. That's why you want to be totally random. But for the sake of this conversation, what I'm saying is every hour we collect 10 samples, okay, and we look for, and that is called the sample. The sample has n observations, okay, and the confusion there, which I mentioned in class, it's sort of analogous to accounting, where you have to keep track of what the difference between a debit and credit is. In here, you have to implant in your brain what the sample is. Sample is a number of readings like this. It's not pulling one off the line, which is easy to do. We'll call that an observation. So a sample is a group of 10, and that data gets packaged up and sent off. The next hour, you pick 10 random cars for the hour in there, and when you plot its data, it might look something like this. And what I'm showing here is the average of the first sample's data. The average is here, is we're going to call that X bar 1, X bar 2. Get it? Okay? And you're going to have 24 of these if it's a 24/7 operation. You're going to have all these samples are going to have a little bit of variance in the mean of those 10. Okay? Now that's what's different now. Now when we look at that nomenclature, we're looking at what they call the mean of these averages. You've got to keep that clear. Make sure you start out on the right foot here. That's why I'm bothering to make this now running longer video about this. This is what we're talking about. Now we're going to collect those averages. We're going to have we'll call it X1, I'm sorry, X1 through X10, and we can take the average of them. Okay, so that's what we're talking about. It's the mean of these averages of the samples. That's a brainful right there. Okay, I just want to make sure if you start out on the right foot and continue and keep that in mind, that's what we're talking about. You just have to keep situational awareness. It doesn't help to cram on these homeworks or any other things in this course, because you have to live with this. And as I said, tease the numbers, understand, draw it out. There's no straight line through this. It's working it out, memorizing it, and the next day trying it out again and making sure you go back that you really understand all this. All right. Okay. So what the problem is that we covered right here, the other part that we talk about in here is the variance of the means. Okay, we're going to look at we can look at the variance. See, now we have 10 readings after we take 10 samples of 10 each. Okay, 10 observations. Then we have these 10 averages, and we're going to look at the standard deviation amongst these averages, and we're using tools like raw data. Okay. For some of you, that might be a big haha. Okay, so this is what we're tracking. This is when a factory normally, when you look at the statistical output of what you're looking at, you're not measuring exhaustively every item that you need to, every report, the timing on every report, how long it took, or how hot a product is, or the mileage of a car. You can't do exhaustive testing. This is the science of this testing. Okay, so you're learning the language and methodology of inside a company, how you use statistics to improve and monitor and whatnot. Okay, so that should be clear. 7.3 relates to the binomial discrete function of chapter 5, if it is. Chapter 7.2 started out more on the continuous world of chapter 6. Okay, so what happens here in 7.3 is it's analogous to the difference between, or the similarities among 5 and 6. Okay, so we're going to look at flipping a coin, right? Remember what binomial is. If you flip a coin 100 times, okay, you end up with a chart that looks like this. It's discrete, and it says what's the probability? How many? If we flip a coin 100 times, there's some probability that none of them are going to come up heads, and there's some probability that it's going to come up with 100 heads. Okay, and as you start working out your problem there, which is is n choose x, how many that we're going to look at there. If you get into n factorial over x factorial over x minus n, I'm sorry, other way around, n minus x factorial Probability of x is the number of times that it came up positive times 1 minus p times the times it came up negative, like that. Okay? All right, remember that equation? And these are these combinations. We have to figure it out. 100 flips, and if you get 25 heads on it, this equation here, whoops, that's a divide sign, and this equation here is the one for binomial. Okay, right? And what ends up happening, we know, and it becomes out logical. If you ran this in Excel and you push in all these numbers here, n is 100, and then x, let x be 0 through 100, and build up a table, you're going to find out that here's 50 here, and it's most likely that on flipping a coin in all of this, it's going to look like this. It's the discrete form of the normal distribution. Okay? And if you notice, it's going to be symmetric like this, like that. It's like a dinosaur. All right? So what is all this saying is it's most likely that if you flip a coin 100 times, you are going to get 50 heads, 50 tails on there because it's pretty evenly split. Okay? And that's what section 7.3 is talking about these problems. 7.2 is talking about continuous problems. Hopefully that helps. It gives you situational awareness. Keep in mind, and as you look at the equation there, you can see where they tie in together. And I hope that helps.